Welcome to the House of Maths. Today I'm going to look at fractions, the basics. So if you look at my little diagram on the board here, just imagine that this is a pie or a pizza or something like that. Now, each little bit is a fraction of the whole. So there are 8 pieces in there. So each piece, they're all the same size. Each piece is 1/8. Okay, and in the pizza there are in total 8 eighths, and that equals 1, and that's the whole of the pizza. So a fraction is part of a whole. The whole is 1, and the fraction is a smaller part of it. So a fraction is going to be less than 1. In this example here, we've got each bit is 1/8. So that is the fraction. Each part of that is an eighth, and that is a part of the whole. Now, if you've got, for example, I've got those two there, 2/8. And if I add to that, say 3/8, so I'm going to put another 3/8 in here. How much have I got altogether? So I've got those 2 plus those 3. Well, that's 5/8. Like so. Now, hopefully what you'll notice here is that these bits at the bottom are the same. If they are the same, we can just add these bits at the top and we get 5/8. Okay, so all that is in here is 5/8 of the whole. Okay, so what are these bits here? What do we call this bit? What do we call that bit? They've got their own names. The bit at the top is the numerator, and the bit at the bottom is the denominator. And as I say, we can add them together like so. If the denominators are the same, we just add the numerators. And the same thing works if we are subtracting. So here we've got, let's say 8/8, and I want to work out this gap. What have we got missing? Well, we know the total's 8/8, and the bit that we've got here is 5/8. I know the maths is easy here. Okay, so we're doing 8. Now we've got to subtract in here. So 8 take 5 is 3/8. So what we're missing is 3/8, and you can see that 3/8 are there. So if we are subtracting, the denominators are the same, we just subtract the numerators. Now what happens if the denominators are not the same? So in this example, we've got 3/5 plus 2/10, and you can see denominators are not the same, so we can't just add the numerators together to work out this one. We've got to change the fractions a little bit to make life easy for ourselves. And the way we do this is we're going to try and get the denominators the same, because then you can just add the numerators. Now, what we can do in this one, I'm looking at this fraction here, and I can see that if I was to double it, I would get 10 in the denominator, and that's what I want. I want it the same as the other one. So this one, I'm going to, if you like, I'm going to upscale it. So I'm going to multiply it by 2. So I've got to multiply the top and the bottom by 2. So I'm going to get 6/10. So this fraction here It's not exactly the same as that because obviously the numbers are different, but it is what we would call an equivalent fraction. So if you put that, if you did 3 divided by 5 in your calculator, you would get 0.6. And if you did 6 divided by 10 in your calculator, you'd also get 0.6. So they generate the same answer. So all we've done is we've created an equivalent fraction here, which has meant we can now add these two together. So we've got 6 plus 2 is 8 over 10. So we've added these two fractions together that have got different denominators. Now, it's a good practice to simplify the fraction if we can. And in this case, we definitely can. So it's easy to halve the top, halve the bottom is a good strategy. So if I halve that, I get 4. If I halve that, I get 5. And you can't go any further than that. We've got a prime number here, so we're not going to be able to do anything with that. So that's our answer, 4/5. Now the same thing happens, exactly the same process, if you are subtracting. There's no difference apart from the fact you're going to have a subtracting here. Now, what happens if we can't just easily upscale one of these fractions? Okay, we've got another question here, 5/6 plus 2/7. Well, I can't just double this one because that's not going to get me 7 there, is it? So what we're going to do here, we're going to have to change both of the fractions. So what we're really looking for is a number that these two are going to multiply up to. So we're looking for something called the lowest common multiple. Now, in this case, it's most of the time it's going to be achieved by just multiplying these two together. So if we multiply those two together, we're going to get 42, and that will be the denominator for this. 6 times 7, 42. We can write these two fractions, or we can come up with two equivalent fractions with the denominator of 42. So we've had to multiply this 6 up by 7 to get 42. So we've got to multiply the 5 by 7 as well, and that will give us 35. We've had to multiply this 7 up by 6 to get 42. So we've got to multiply this numerator by 6 as well. So that's going to give us 12. And now we can just add these together. So 35 plus 12 is 47. Okay. Now, what we've got here in our answer is an improper fraction. Okay, it's called an improper fraction because the top is bigger than the bottom, and it's clearly more than 1. Okay, so we wouldn't ordinarily leave that like that. We would turn this into a mixed number, and we do this by asking ourselves, how many times does 42 go into 47? Hopefully you can see that it goes in once. And there's going to be 42 goes in once, and that's 42. And there's another 5 left to get up to 47. So we're going to be left with 5 and 42 underneath. 42 is going to stay as the denominator. So we've converted that into a mixed number, which is what we need to do to complete this question. So you can see that if these two numbers, if you can't easily upscale one, you have to change both of them. So I've rewritten these two fractions over 42. Now there's a slightly different way of looking at this, which I'll show you. You may prefer this. Quite often it's, well, I've heard it referred to as the smiley face method. So what you would do with this is multiply these two together to give 42, and then times these two together to give 35, put a plus because we're adding, and then times those two together. 6 times 2 is 12, and that is 47 over 42, which is the same answer we got before, obviously, because it's the same question, but it's just a different way of looking at the problem. Some people prefer to do it in that way rather than writing underneath two equivalent fractions. So smiley face method, if you like that one, use that. Okay, so that's adding and subtracting. What about multiplying? So multiplying is probably the easiest fraction operation with fractions that you need to do. With this fraction here, you just multiply that by that and that by that. Okay, so 6 times 2 is 12, 7 times 5, 35, and that's it. That's all you need to know on multiplication. Well, there is one other thing. If, for example, you get mixed numbers to multiply, you do have to be careful. So if I've got to multiply those together, what you can't do is just do 2 times 3 and then do the fractions. You've got to convert these into improper fractions first and then multiply. Okay, so it gives us the opportunity to look at how do we do this, how do we actually convert these into improper fractions. Well, the method is you take the 5, multiply it by 3, which is 15, and add 1, which is 16. And it will always be, whatever you've got here, whatever denominator you've got here, will always be here. And then you do the same thing here. You do 3 times 2, which is 6, plus 2, which is 8. And put that over 3. And then you can do the multiplication. So 5 times 3 is 15. And obviously this one's a bit harder, isn't it? 8 times 16. Let's do 8 tens are 80. And 8 sixes are 48. So that's 128. Okay. And then we've got to work out how many 15s go into 128. So we've got 6 in 90. 8 in 120, so we're going to get 8, and there's 8 left. Okay, so we can then convert that into a mixed number. That's not going to simplify anymore, so we can leave it like that. Okay, so multiplication, multiply across the top and across the bottom. If you do have mixed numbers, make sure you convert them into improper fractions first, and then do the multiplication. Okay, that's multiplication. And the last one I'm going to look at is division. So what if you have okay, we've got a division here. Well, we resort to a bit of trickery with this, and we use something, a little method I've heard used before. It's just called keep, change, flip. So we keep this one the same. So I'll write that underneath, 5/8. Then we change the division to a multiplication, and then to make this work, we invert this one or flip this. So we've got 3 over 2, and then we've converted the division into a multiplication. So we can then do 5 times 3 is 15, 2 times 8 is 16, and then we're done. And that's how you deal with division. Okay, that's my basics on fractions and how to handle the 4 operations: adding, subtracting, multiplying and division. If you like that, hit the like button and consider subscribing. Thanks for watching.